going to look at a series of dihydrogen species, and we're going to work out their bond orders. So we're going to have for all of them, so this will be sigma 1s and sigma star 1s. So I'll start with H2, which we just met. I'll do H2 plus, H2 minus, and H2 2 minus. And I'm going to ask for the bond order for each of them. Yeah. So that's 1, 2, 3, 4. Well, before bond order, I'm going to ask for the electronic configuration and then the bond order. So dihydrogen, H2, has 2 hydrogen atoms coming together, each bringing 1 electron. So that's 2 electrons. According to all 4 principle, first goes here. Pauli's exclusion principle says I can spin pair them. That's that. So for H2, my EC is sigma 1s2. My bond order is 1 bond pair minus 0 bond pairs, which is 1. So I'm going to describe this as H single bond H. What about H2 plus? Well, if I'm doing Lewis structures, H2 plus would have had 1 electron, it would be 2 times 1 for the electrons that each hydrogen brings. Each H is equal to 1. Each will bring 1 electron, minus 1 for the positive charge. And of course it is. H2 has 2 electrons. H2 plus will be missing an electron, hence it only got 1. Where is it? Well, according to the all 4 principle, it'll be in sigma 1s. So what's the EC? It'll be sigma 1s1. What's the bond order? Well, I've got half a bond pair, 1 is half of 2, minus 0 anti-bonding pairs, so my bond order is a half. So if I had to draw that species, I would say it's H, dotted line H, and the whole thing has a 1 plus charge. That's what it looks like. It's called a molecular ion. What about H2 minus? Well, how many electrons does that have? Well, each H brings 1, so that's 1 each, that's 2, and there's another one with a minus charge, so there are 3. Where are they? All 4 principle, 1. Pauli exclusion principle, 2. And the third one goes here. What's my EC? Well, so what's my configuration? Yes. So it's sigma 1s2, sigma star 1s1. What's my bond order? Well, it's 1 pair minus half a pair, which is half. So H2 minus looks very much like H2 plus, except the charge has changed. And if I were to ask you, well, if I look at those 3 species, what can I say about the stability? Well, clearly, if I've got a whole bond keeping things together, that's more stable than a half a bond. And we won't mess with the chart. It's not good. What about H2 2 minus? How many electrons do I have there? Well, there are 4. 1, 2, 3, 4. So what would the EC be? It would be sigma 1s2, sigma star 1s2. What's my bond order? It's 1 pair minus 1 anti-bonding pair, which is 0. In other words, there is no bond. If there is no bond between the atoms, then the species does not exist. Right? In other words, H2 2 minus has no real existence, right? Because there's nothing holding the HH atoms together. By the way, helium is also a period 1 element. So helium also has access to the 1s and the 1s orbitals only. So what if I were to include HHE, HE2, and HE2 plus, for example? Let's say I could. What would the ECs of those be? So I've got the same menu of sigma and sigma star. He2, helium has 2 electrons, so the 2 of them, that's 4. So that's 1, 2, 3, 4. That is the same as H2 2 minus, which is why dihelium has no existence, because the bond order is 0. And I would say that these two species are isoelectronic. That's a term you met in Gen Chem 1. Right? They've got the same number of electrons, so the same electronic configuration. What about HHE? Could that exist? Well, let's see. How many electrons are there? 1 for the H, 2 for the HE, that's 3. 1, 2, 3. That is isoelectronic, right? That is isoelectronic with H2 minus, right? So these two are isoelectronic, meaning that it is possible for HE to exist. Won't be very stable, it's got half a bond, but that's better than 0. What about HE2 plus? Could that exist? Well, how many electrons would I have? I'd have 2 electrons. They would, right? Because each HE is 2 electrons, so 2 times 2 is 4. And the 2 plus charge means I'm missing electrons, so it's going to be that. So technically the bond order is 1, and that is isoelectronic. That is isoelectronic with dihydrogen. Right? That is isoelectronic with dihydrogen. And if I had to ask you, how stable, although the bond order is 1, how stable will that be? Well, for heaven's sake, if I draw it out as HE with a 2 plus charge, what that means is there is massive repulsion. So even though in theory the bond order is unit and the species could potentially exist, the repulsion between those positive charges on adjacent atoms is going to be massive, and that thing will fly apart. It will split itself apart. So He2 plus, even though the bond order is unit, it's not going to be a stable entity because the repulsion between the like charges would make the molecule fracture. Right? So although it's got the same bond order as H2, one has an existence, one does not. Okay. I think we stop there for today, and we'll pick up here on the next lecture. Okay, thank you guys.